This is a standard aircraft control and warning station of Continental Air Defense, United States Air Force. It is equipped with surveillance and height-finding radars, related electronic equipment, and extensive communications facilities. It is manned by a crew whose primary mission is to intercept hostile aircraft. In order to determine which are the hostiles that must be intercepted, the members of this crew must first detect and identify every aircraft which enters the station's area of responsibility.
Did you receive any more flight plans? None whatsoever. Sir, track 37 unknown.
Because America's security from attack depends on the alertness and efficiency of the air defense net, the proficiency of every aircraft control and warning crew in each division is a measure of the strength or weakness of our air defense. It's a relatively simple task for Air Force training centers to train each individual to operate any single piece of electronic equipment, to direct interceptors, to correlate flight plans with tracks, or to perform the special skills required at the plotting boards. However, training the crew to function rapidly and accurately as a team is a difficult problem, since the air situation presented to the crew is necessarily limited to the normal amount of air traffic in the vicinity, amplified on rare occasions by real air missions which are far too costly to schedule often. Even less training is available to the crews manning America's most critical aircraft control and warning stations. Those located at outposts covering the lonely, low aerial traffic areas along the border, over which a surprise aerial attack by a reasonably intelligent enemy is most likely to be launched. This, then, is the problem. It is vital to America's defense that these AC&W crews be continuously and effectively trained, and not only as a unit, but as an integral part of the air defense system. But how can it be done? Early in 1951, the RAND Corporation, established to provide the Air Force with independent, objective analyses of the broad problems of air warfare, set up a system research laboratory to carry out experimental studies of human learning in organizations involving both men and machines. Because the Air Defense Direction Center appeared to be an organization which could be studied in the laboratory under controlled conditions, a direction center was the first to be simulated. Around this simulated direction center were placed observation balconies from which training specialists and other scientists could study the application of various types of training procedures. Everything that each test crew did or said was monitored, recorded, and analyzed. From this research emerged certain basic training principles for air defense improvement through proper crew training. These principles are: exercise the team as a whole, not as individuals. Exercise the crew frequently. Make sure that the simulation of all essential conditions be as true to life as possible. The crew must receive immediate and complete knowledge of results achieved and be given an opportunity to discuss their performance in the exercise just completed. The crew and training personnel must always bear in mind that the exercises are not tests, but practice, training, and that the inevitable mistakes help the training process by indicating where improvement is possible. It was soon confirmed that a direction center crew was only part of the team to be exercised. The division, with its network of radar stations, was a more appropriate sized team to train. Surveillance and interception of critical flights, which penetrated the control area of each radar station in the division, required complete interaction and cross-telling of information between the stations, as well as forward-telling to the division. The solution to these requirements involved modifications to an IBM digital electronic computer, the use of a digital analog converter, the design of a special cathode ray tube, the adaptation of a 70mm motion picture camera, the modification of tabulating equipment to print maps for installation at the direction center, the design and manufacture of problem-reproducing equipment. Each training exercise provides plausible and realistic simulation of important details likely to be encountered in real life. The blips on the scopes appear, move, fade, and otherwise behave like the blips for real aircraft in the particular station's area. Problems are programmed to present a normal traffic pattern on the scopes, with the addition of flights of hostiles or unknowns. The informational inputs from sources other than radar are presented, insofar as the crew is concerned, with equal realism. Flight plan reports from CAA.
I have a northbound, United 37, DC-6, speed 230.
Cross-telling for neighboring defense areas.
Initial plot at Baker George, 2051, time 26.
And reports from pilots of interceptors.
Anderson Gilding 25, heads up 1, out.
It is also of extreme importance that the information about aircraft, whether friendly or hostile, be complete, accurate, and therefore irrefutable. Through the use of IBM tabulating machines, each flight path is converted to statistical information in a form capable of being programmed into an electronic computer. Meanwhile, a problem design group, in consultation with military advisors of an Air Defense Command task group, selects the types, paths, and sizes of hostile flights desired for a training problem. And these also are converted to IBM cards. For maximum realism, points of fades, interference, and other characteristics of radar performance in each station's area are also prepared for computation. All this information is then programmed for correlated computation by a high-speed digital electronic computer. For a 2-hour problem containing a total of 200 tracks in sight at any one time, approximately 500,000 blip positions must be computed for a division with 5 radar stations. The computer converts all the specifications into spots on photographic film, which is in the form for use at a station. This film, when fed through the problem reproducer, forms a video input for the scopes, on which the film spots reproduce like blips representing real aircraft. both on the PPIs and on the height finders. The same electronic computations are used to produce the training materials required, like the correlation maps, consisting of non-radar maps which give positive and complete information about every flight in the air that does not appear on the radar scopes, and the radar maps, which give training personnel information about every flight which does appear on the radar scopes. The Training Operations Report, or TOR, maps, consisting of separate maps containing all penetrating tracks, including all hostiles and friendlies without flight plan, and used by the TOR team to note the performance of a direction center crew. The cross-tell maps, showing all tracks entering or leaving the area controlled by a simulated adjacent division, and used to receive or pass on cross-telling information. The flight plan information script, which gives the proper call-in time for the flight plan information provided by STP for use by the simulated CAA representative. And the flight reference list, which lists all flights, hostiles and friendlies, for quick reference during the problem as to any detail of speed, course, and time of first appearance on the scope. In the field, division-wide STP exercises can be scheduled frequently, without regard to time of day or night, without regard to weather and flying conditions, which might cancel out real air missions, and while still maintaining adequate defense. In each radar station of the division, clocks are set at the starting time for the particular STP problem scheduled. Problem reproducers are started. And then, throughout the division, the crews to be exercised now can begin work. Scope readers watch for tracks, while the Movement Identification Section, MI, receives flight plan information on military and commercial flights. As tracks develop, they are told to the plotters who plot them on the board. All unknown tracks are forward told to the Division Control Center. The plotters also enter the tracks cross-told from other radar stations in the division or neighboring defense areas. MI checks each new track against the flight plan information it has received. If MI declares a track unknown, a scramble is ordered.
Track 12 is unknown.
Sergeant, let's get two gelding off for Victor 37, Vector 250, Angels 40, gate, and give Andy a call on 13.
Right, sir. Gelding, this is Anderson. Scramble 2, Victor 250, Angels 40.
As in normal operations, the number of interceptors scrambled depends on the number of aircraft estimated in the unknown track. The interceptor pilot uses the 15J1C to simulate interceptors scrambled at the time and speed consistent with realistic operations. The intercept directors follow each intercept mission on their scopes, vectoring interceptors on the target. When positions of interceptor and target blips indicate that visual sighting is possible, the interceptor pilot tally-hoes.
Anderson, this is Gelding 2-5. Tally-ho.
Gelding 2-5, this is Anderson. Close for identification.
When directed to do so, he proceeds to close and identify aircraft by type, owner, and serial number. As the problem continues, all of the station's procedures and functions are exercised. And the radar station's crew is trained as an integral part of the division team. STP exercises are progressively scheduled. As crews learn to handle simple problems, the number of tracks and the complexity of air traffic is increased, and a variety of emergency situations are introduced, thus gradually developing each crew's ability to function efficiently under wartime conditions of defense. Specific problems are designed to place particular stress on the capabilities of any single function, like forward telling, cross-telling, plotting, or MI. Unlike real air missions, there is no delay in verifying the results.
Baker crew will have a post-exercise discussion in the training room in 5 minutes.
At the completion of each STP training exercise, the crews are immediately presented by the tour team with the facts about their performance. And the facts are complete and accurate. No attempt is made by the tour team to assign the blame or establish the responsibility for error or failure on any of the crew members. The tour team should not stay for the post-exercise conference. Instead, the members of the crew are encouraged to analyze their own problems and work out improved procedures by themselves. Since it costs nothing to make a mistake during an STP exercise, new ideas can be tried. Trial and error encouraged. These post-exercise conferences involve all crew members in problem solving, thus contributing to motivation, morale, and a feeling of group responsibility, all of which are important to improving the team's learning, efficiency, and cooperation. What is happening at this station is being repeated at each radar station in the division, as well as at division headquarters, where the control center crew also participates in a post-exercise conference and analysis of action taken by headquarters. Conferences must be held immediately after each exercise for discussion and analysis by the crew itself. That will increase the operating proficiency of direction center crews in every division, and thereby increase the effectiveness of America's air defense.